Right, in this question we're asked to find whether any of these lines are perpendicular at right angles. Okay, now in order to tell this we should have hopefully watched a video about how we know whether lines are perpendicular by looking at their gradients, and you should know that y equals mx plus c is the thing we're going to be looking at, where the m, the number next to x, is the gradient. Okay, so we've got the gradient here. So what I'm going to try and do is I'm going to try and rearrange all these so that they're in this form of y equals mx plus c, so that I can see what the gradient is and therefore tell whether we've got perpendicular lines or not. So this first one already in the form y equals mx plus c, so we've got the gradient here of, and what number's next to x? Well, 4. So the gradient of 4 there. Next one isn't quite, so what I'm going to do is I'm going to get the 4x over to the other side, so y equals, and when that goes over to the other side it becomes negative 4x plus 6. All right, so the gradient here, and my pen is running out, gradient equals negative 4, the number next to x there. Okay, so there's 2 done. They are not perpendicular because basically when we find a perpendicular line you turn the fraction upside down, change the sign. The signs are different, but we haven't turned the fraction upside down, so they are not perpendicular. If I look at this one, if I'm going to get it into y equals mx plus c, I've got 4 y's, I only want 1 y, so y equals, and I've got to divide this by 4, so 1x divided by 4 is a quarter of x, take away, oh, not plus, sorry, do apologise, minus 5 over 4. Okay, now the gradient there, gradient equals, well, it's this value here, isn't it? Equals plus a quarter. So there we go. Oh, we look like we're getting some fractions involved now, so that's a good thing, that's a positive sign. Now then, the last one, I need to get all this stuff over to the other side, so I'm going to be left with 4y equals, now we got negative x and plus 12. Okay, I don't want 4 y's, I want 1 y. So I want negative a quarter of x plus, well, 12 divided by 4 is 3. Now the gradient of this one is, and it's this one here, negative a quarter. So now we've got some fractions involved. So which ones are perpendicular? Well, if I look at this one, A, now if the gradient here was 4, the gradient of the perpendicular line is going to be minus a quarter, so that's the bottom one there. So A and D go together, so why don't I draw a line between those two? Okay, now that should mean that B and C are either linked or not linked at all. So B, the gradient was negative 4. Now the perpendicular line, I turn the fraction over, which gives me a quarter, negative a quarter, but then I change the sign, so I get positive a quarter. Fantastic. So those two are also perpendicular. So I have 2 pairs of perpendicular lines. I've got A and D and B and C.
Okay, Mary, so let's have a look at this one. So solve x plus 2x equals 12. So what do you think you do first?
Okay, well, I want x on its own, so I would put x equals 12 minus 2x.
Okay, so a lot of the time we want to get x by itself, but what we want to do first is get all of these x's together. So can you see anything we can do with this? Get all these together in one place.
Oh, okay, it's 3x, isn't it?
Yeah,
so
absolutely.
3x equals 12. Oh, and so x equals 4.
Brilliant, spot on, well done.